overlapping regular hexagons are drawn such that their intersection forms a quadrilateral. A line passes through a vertex of each hexagon so that angles x, y, and z are formed as shown. Find the measure of z in terms of x and y in degrees. This question is from the final round of the 2024 UP Math Club's annual nationwide search for the Math Wizard, which is one of the most prestigious collegiate math contests in the Philippines. This is a buzzer-type question, good for 60 seconds, which means that only the first person to provide the correct answer within the time limit gets the point. Pause this video first and try if you can answer within the time limit. For the sake of this discussion, let's label the vertices as A, B, C, and so on until L. As with any other angle-chasing problems, it could be useful to identify which ones have already known values. Since we have regular hexagons here, the vertex angles each measure 120 degrees. Next, let's label the points of intersection of the two hexagons. Let's call them points M and N. What we know now is to establish, or what we need now is to establish a relationship between the angles in quadrilateral in the middle and the angles with measure x and y. To do this, let's create a triangle that could sort of bridge the quadrilateral to the other angles. We extend side AB to the top line and label the intersection point as point O. We can look at the straight line containing point I to conclude that x plus 120 plus the measure of angle NIO is equal to 180 degrees. Thus, the measure of angle NIO is 60 minus x. We can use a similar reasoning to conclude that the measure of angle BCO is 60 minus y. Meanwhile, angle CBO is a supplement of a 120-degree angle, so its measure must be 60 degrees. Now we can use the exterior angle theorem on triangle BOC to conclude that the measure of angle NOI is 60 minus y plus 60, or simply 120 minus y. So now we have the measure of both angles NOI and NIO. With their measures, we can immediately find the measure of angle ONI, knowing that they should add up to 180 degrees. Therefore, angle ONI measures x plus y degrees. By the vertical angles theorem, angle ANJ could also measure x plus y. And now we have all the angles for the quadrilateral. Recall that for any quadrilateral, the interior angles should add up to 360 degrees. Thus, we get that 120 plus x plus y plus 120 plus z is equal to 360. Simple algebra gives that the expression for z is 120 minus x minus y. Therefore, the value of z that we want in terms of x and y is 120 minus x minus y, and that's our final answer. It's quite simple once you start on the right track, but I understand that anyone could get stuck with this problem if sidetracked by other elements of the diagram. As they say, practice makes perfect, so my advice is just to keep on similar problems to improve your intuition on where to start. Anyway, I hope you learned something from me today. If you have any, or if you have an alternative solution for this problem or any comments, clarifications, or violent reactions, just let me know in the comments. See you on the next one. Bye-bye.